Hey, this is Mr. James. In this video, we'll be talking about slope, parallel, and perpendicular lines. Before we can get to the parallel and perpendicular lines, though, we'll need to review slope and slope-intercept form. I'd like you to go ahead and try questions 1 through 5 on your own, and graph the following 3 graphs at the middle of this page. If you're having trouble with any of these, please go back and refer to the previous video. The answers will be coming up in 3, 2, make sure you try these on your own, because all of this are important prerequisite skills. Here are the answers. Here are some of my answers for the first section. Pause the video if you need to write any of these down or check your work. And here are my 3 graphs. Again, pause the video if you need to check your work. And here we have all 6 lines. Now, make sure you're graphing these correctly. If you need to correct something on your paper, just erase it and try again. Some things to watch out for is the negative slopes, right? Make sure that negative 3 over 2, you're going down 3 over 2. Make sure when you graph this slope of 3 right here, it's 3 over 1, so you're going up 3 and over 1. And also make sure you're getting these y equals 2 and x equals negative 1 lines correct. Remember, y equals 2 is that horizontal line, and x equals negative 1 is that vertical line. And it might help you, like I did, to graph these in 2 different colors. So if you didn't do that originally, you can always go back and change it, or perhaps even highlight or go over the lines you've already drawn. Could help you now and in the future. So let's start talking about our main event here, the parallel and perpendicular slopes. The interesting thing about the 3 graphs we just created were that every pair of lines was either parallel or perpendicular to each other. Let's start by looking at the second graph right here, where we have the line y equals 3x minus 1 and the line y equals 3x minus 4. They appear to be parallel. Why is that? Well, that can be explained by looking at the slopes. Both of the slopes in those lines are 3. They're equal to each other. So it seems like when we have slopes that are equal, we create parallel lines. Now that kind of makes sense because the slope tells you how steep the line is, the rise and the run. And if 2 lines have the same steepness, then they're going to carry on with the same rate of increase or decrease and never intersect each other. So let's make a note of that down here. The slopes of parallel lines are always equal to each other. So I've put a quick example here. Y equals negative 7/8 x plus 4, and y equals negative 7/8 x plus 6. It doesn't really matter what the x-intercept is. That'll just control how close or how far apart our parallel lines are. But to make them parallel, they've got to have the same slope, equal slopes. Well, those were parallel lines, but what about perpendicular lines? Lines that intersect at a 90-degree angle. Well, if we look at the first graph here, it seems like we've got 2 lines that are perpendicular. They intersect at a 90-degree angle, or right angle there. Well, let's look at the actual lines, the equations of the lines. The blue one is y equals negative 3/2 x minus 1, and the red one is 2/3 x. I guess we could call it 2/3 x plus 0, because the y-intercept here is 0. But what we're really interested in is the slopes. The blue line has a slope of negative 3 over 2, and the red line has a slope of positive 2/3. You may see a little pattern here. One slope is positive and one slope is negative, which means these 2 slopes have opposite signs, positive and negative. In addition, the fractions here are flipped. One is 3 over 2, the other is 2 over 3. We call that being reciprocal. So it seems like 2 perpendicular lines have opposite signs and reciprocal slopes. Let's put a couple notes down here. The slopes of perpendicular lines are opposite reciprocals to each other. Opposite means we're going to change the positive and negative sign, and reciprocal means we're going to flip the fraction over, the numerator and the denominator. So here's an example. If I had y equals 3x plus 4, the slope of the first line was 3. So the slope of 3. Now I'm going to change the positive and negative sign, so my new slope for a perpendicular line would be negative 3. But also, remember, 3 is the same as 3 over 1. So the reciprocal slope, flipping the fraction over, would be negative 1/3. And that's what I have here. Y equals negative 1/3 x minus 7. Just like parallel lines, the y-intercept doesn't matter at all. Could be anything. But as long as the slopes are opposite reciprocals, flip the fraction, change the sign, and you'll get perpendicular 90-degree slopes. One last thing I wanted to mention is on this third graph here. We have a horizontal line, y equals 2, and a vertical line, x equals negative 1. Now, remembering from the review, we know that the slope of this horizontal line is 0. Okay? and that the slope of the vertical line is undefined. It turns out that a zero slope and an undefined slope are also perpendicular to each other. Now, this actually makes sense with the opposite reciprocal note from before, because if you think about a slope of 0 is the same as 0 over any number, let's say 1. And an undefined slope we get from dividing by 0, a slope like any number divided by 0. And if you look at these two slopes, the fractions are flipped over. The numerator and the denominators are reciprocals of each other, right? So even though we say a zero slope and an undefined slope are perpendicular, really we're still saying that opposite reciprocal slopes are perpendicular. Let's flip to the backside to determine whether lines are parallel or perpendicular without a graph. Are these sets of lines parallel, perpendicular, or neither? Pause the video here and look at each pair of lines and determine whether those lines are parallel, perpendicular, or neither. And think about why they might be parallel or perpendicular. Pause the video now. The answers for 1 through 4 will be up in 3, 2, 1. Alright, let's take a look. Number 1, the slope of both equations is 2. It's the same slope, which means that those two lines will be parallel. For number 2, the slope is 3 1/3. Now you might think that that's a keep flip change slope, that those are perpendicular. But actually, 3 1/3 are flipped over the fraction, right? 3 over 1 changes to 1 over 3, but you've also got to remember to change the sign. And the second slope isn't negative, it's a positive 1/3. And so it's not actually keep flip change, it's not a negative reciprocal, because it's not negative. So this ends up being neither. For number 3, x equals 2 and y equals 5. Well, x equals 2 is always a vertical line, and y equals 5 is always a horizontal line. You could graph those if you wanted to see this a little more specifically, but I know since that's vertical, this is horizontal, this will be a perpendicular set of lines. We'll come at number 4. Can we figure out what the slopes are of those two equations right away? We actually can't, right? They're not in y equals mx plus b form. So to make things easier, let's put these in y equals mx plus b form. We write them next to each other just like this. Okay, let's take a look at this first one. We need to get this into y equals mx plus b to figure out what the slope is. So here's a y. I need to get y by itself. So I need to move this 2x to the other side of the equation. I'll subtract it from both sides. Okay, and I'm left with y equals. Now I can't combine 3 and negative 2x because those are not like terms. One has an x, one does not. So that means I'll leave this as negative 2x plus 3. And so the equation of this line is y equals negative 2x plus 3. What about the other line? Well, I'll do the same thing. I'll subtract 4x from both sides. So I get 2y equals negative 4x plus 10. Again, I couldn't combine the 10 and the negative 4x. It's not like terms, so I just wrote it like this. But y is not by itself yet. There's 2 times y over here. So the opposite of multiplication is division. So I'll divide both sides by 2 to get y by itself. And now I'm going to divide everything on the right-hand side over here by 2. So that leaves me with negative 2x plus 5. And now if we look at these two equations and their slopes, that has a slope of negative 2, this has a slope of negative 2. Actually, those two lines are parallel. They're parallel. They're parallel because they have the same slope. Now that you've seen 1 through 4, go ahead and try looking at 5, 6, 7, and 8. Again, the answers will be up in 3, 2, 1. For 5, we have slopes of 2 and negative 1/2. Those are keep flip change. Remember, 2 over 1, flip that fraction over, 1 over 2, change the sign to negative. Those are in fact perpendicular. Something like 6, well, the slopes are 5 and negative 5, and they look like they're the same, but they're not. One's positive, one's negative, so they're definitely not parallel. And there's no flipping of the fraction, there's no reciprocals, so they're definitely not perpendicular. These are neither. For 7, we've got x equals 2, which is usually a vertical line, and x equals 5, which is again another vertical line. They both have that same undefined slope going straight up. So those are going to be parallel. Number 8 is what we call in point slope form, which we'll work more with in a second. But point slope form looks like this. Y minus y1 equals the slope times x minus x1. And when we look at these up here, that means the slope is this number, 2/3 and negative 3 over 2. And that is a keep, flip, change slope. So these lines are perpendicular. We can also find the equation of a line that passes through a following point if we already know another line that's parallel or perpendicular to it. For example, in number 1, we want a line that passes through negative 4, 2 and is parallel to y equals 2x plus 3. Now you may remember from previous videos that whenever we write an equation, we need to know two things. We need to know the slope and we need to know the y-intercept. And in fact, you already know the slope just by looking at the question. Remember that parallel lines have the same slope, so we'll take the same exact slope that this line has, and that will be the slope of our new line. So the slope of our new line is 2. But we don't know the y-intercept, so we need to find the y-intercept using the method we've learned in previous videos. Start with the equation, y equals 2x, but we don't know the y-intercept, so we'll put plus b. Using the coordinates at this point, negative 4 for x and 2 for y, we'll substitute in, bringing down the slope and the plus b, and then we'll solve. 2 times negative 4 is negative 8, sorry. Bring down the 2 and the plus b, and now we'll add 8 to both sides to isolate that b, get it by itself, and 2 minus 8 is negative 6 for b. So it turns out my y-intercept is negative 6, and my final answer will be y equals 2x minus 6. Again, we got the slope because we know that the two lines are parallel and they'll have the same slope, 2, and we got the negative 6 by using the process we learned before to find the y-intercept. Let's start 2 together and then I'll have you finish on your own. If we wanted to create a line that goes through negative 4, 2, but is perpendicular to y equals 2x plus 3, well, let's think. Again, we're going to need a slope and a y-intercept. Now, for perpendicular lines, we won't use the same slope as this line. We'll use the opposite reciprocal slope. So remember, 2 can be 2 over 1. And so the opposite slope, this is positive, so we'll have to have our perpendicular slope be negative. And the reciprocal, flipping that fraction over, that'll be 1 over 2, or 1/2. So my slope will be negative 1/2 x. Now, let's find the y-intercept. And I'm going to let you do this on your own. Pause the video. Use what we've learned before and our new slope of negative 1/2 to find your new y-intercept. The answers will be up in 3, 2, 1. So I got 0 equals b, so my y-intercept is 0, and so my final answer, my line is y equals negative 1/2 x plus 0, or since we really don't even have to label 0 on there, we could leave it as y equals negative 1/2 x. That ends this video on parallel and perpendicular slopes. Hope you got everything. Good luck, and I'll see you next class with the video check.